Now this is another question. Generate a grammar for L is equals to AN, BN, CN where N should be greater than equal to 1. Then this is the language that will consist all strings which will have equal number of A's, equal number of B's and equal number of C's. Because if N is equals to 1, string will be ABC. If N is equals to 2, string will be AABBCC. If N is equals to 3, string will be AAABBBCCC. So these kind of strings will be generated by this language. So we have to generate a grammar that will generate this language. So for generating the grammar we need production rules. So let's define the production rules now. So now for generating the production rule, consider the language, it is AN, BN, CN. We will proceed in two parts. First we will consider BN, CN only. BN, CN. After computing this we will merge the result with our original language. So consider, let BN, CN is equals to BC. What is BC now? If N is equals to 1, then the string will be BC. If N is equals to 2, string will be BBCC. If N is equals to 3, string will be BBCC. N is equals to 4, then there will be 4 B's and 4 C's. And BC is a general term for all these strings, BC, BBCC, BBCC. Whether the value of N, whatever it is, all the strings that would be generated by their combination would be under the category BC. So BNCN is equals to BC. We have assumed this. So now we can have a production rule like, take a start symbol S1, because we cannot take S. S can be taken in our original expression only. So we are taking S1 here. S1 derives BC. Now if this is a production rule, then we can say that S1 derives BC means from this start symbol we can derive BC. And what is BC? Any string which is a combination of B and C such that B comes before C and B and C are equal in number. This is also capital BC, this is also under BC, this is also under BC. So a single production can derive all the strings of B and CN. So this production is enough for this language. Now consider A and B and CN. For this we will consider start symbol S, our original start symbol, that can produce a single A, and then S1, that is, this can produce single A and BC, and BC can be single B and single C. When N is equals to 1, it will be A, B, C. Or S can produce a production like A, S, S1, where we can put recursively any number of A's by substituting AS1 in place of this S, or again substituting in the place of S, AS1 only, we can introduce recursively any number of A's. I have written both the productions here, one for BNCN and that S1 is used in this our main production. So now let's consider this string AABBCC. We have to produce this string using these production rules that we have derived. So here we have two A's. So first use the production AS1, and in place of this S you can substitute AS1. We will get AS1, S1 is as it is. Now we have got two A's and two S1s. So S1 are BC, AA, this S1 is BC, this S1 is also BC. Now we need the string AABBC such that all A's are together, all B's are together and all C's are together. But see here, capital B, capital C, capital B, capital C. B's and C's are occurring alternatively. So we have to derive a production rule that can bring all the B's together and shift all the C's together. So we can have a production rule like CB derives BC. What will happen from this? Consider this CB in between, this one. This CB can be replaced as BC using this production rule. AA, this B as it is, CB is replaced as BC and this C as it is. Now we have got the non-terminal B's and non-terminal C's together. Now there should be a production of some type that can change this non-terminal B to terminal B and non-terminal C to terminal C. So we introduce a production such that this small a capital B, that is the terminal A, non-terminal B, can be replaced with terminal A and terminal B. That means this small a capital B will become small a small b. This is small a, this will become capital B, capital C, capital C. Now we have to replace this B also. So for this we can have a production of this kind. Terminal B and non-terminal B can replace terminal B, terminal B. This will become terminal B, terminal B, terminal A's are already there and two non-terminal C's. So now we have got two A's, two B's, the remaining is two terminal C's. So for this we can have a production like non-terminal B and non-terminal C can be replaced as terminal B, terminal C, and check here, it will become terminal B, terminal C, and this non-terminal C will remain. Now there can be a production to change this. Terminal C and non-terminal C can give two non-terminal C's. So it will finally become AA, B, C, C. We have got our string, and while producing the string we wrote down the production rules that are needed. This is the best way to generate the grammar. Now check for this string also whether we have generated the correct production rules or not. We have to generate this string, so consider this production. S derives A S S1. In place of S we will substitute again A S S1, A S S1, and this S1 is already there. Now we need one more A, so this S can be replaced using AS1 only. A S1 S1 S1. Now what we have to do, S1 is replaced by BC. 3 S1 will be replaced by 3 BCs. A, this was A, BC, BC, BC. Now this CB and this CB can be replaced by BC. It will become A, B as it is. This CB is BC, this CB is also BC, and this C. Now again this CB can be replaced by BC. A, two B's, BC, CC. Now B's are together and C's are together. What we have to do, this production, this AB can be changed as A, small b, capital B, capital B, capital C, capital C, capital C. Now this can be changed as small b, small b. This will also become small b for this production. C, C, C. Now this can be replaced as BC small and two capital C's, which in turn will be replaced by small c's using this production. So we will finally get triple A, triple B, triple C, which is our string. That means the production rules that we have generated are correct. Now we can write the grammar also. Grammar is a 4-tuple NTSP. First we define the non-terminal, then terminals. Grammar is, non-terminals are S, S1, B and C, comma, terminals are small a, small b, small c. S is our start symbol and the production rules are P, where P is all these 7 production rules. 1, 2, 3, 4, 5, 6 and 7. In the place of P, you write all the 7 production rules. This is our grammar for this language. I hope this example is also clear to you. So I hope all the examples that I have discussed for generation of a grammar from a language is now clear to you, and I hope you will be practicing it, because these types of examples will only be clear to you if you practice more and more, because in competitive exams similar questions come, but only due to lack of practice we make large amount of time for each question, which is not required. If you practice beforehand, it will be very easy in the competitive exams. And if you have not subscribed to our channel yet, please hit the subscribe button also, and don't forget to like and share our video. Thank you.